I'm going to talk about the architecture of Tube, its potential applications, and then briefly discuss a very interesting experiment that we are carrying out right here in Princeton. So this schematic shows the essential modules of Tube and the feedback loop. Using economic models, we profile the usage behavior, which, along with network measurements, are fed into the brain of the system, that is the price optimization unit, which solves a large-scale nonlinear optimization problem. The optimizer uh, tries to compute the prices or alternatively rewards that are to be offered to the users for the next 24 hours. And in doing so, it tries to minimize the total cost to the operator, which includes the cost of overshooting capacity in any of these periods and the cost of awarding rewards to the users who are willing to wait. Now, the tricky part is that we need to incorporate the user's reaction to these prices, because for how long I'm willing to wait will depend on what kind of rewards you are offering. And we incorporate this into the model by using weighting functions, which weighs the volume of traffic of that particular class that is deferred out of each time period to other time periods. And the problem is solved under the constraint that the total volume of usage under time dependent pricing is equal to the normal usage plus the total volume across different traffic classes that are going to be deferred in or out of each period. The users get to see the prices on offer for the next 24 hours on their mobile handset, and they get to react to these prices either manually or in an automated mode, that is the autopilot mode, and they can potentially choose to defer their high bandwidth applications to periods of lower price. And the user's reaction to the offered reward and the amount of delay they're willing to tolerate is then used to compute the patience index for different traffic classes, which then gets fed back into the control loop to adjust the future prices. We implemented TDP and tried it for different mix of apps with different time elasticities. And here is a typical graph that we saw. The blue curve shows the total volume of usage from empirical traces for 24 hours without TDP. And the green line shows the new usage pattern for the same 24 hours with time-dependent pricing. And you can see that the peaks and the valleys in the green curve are much closer. And and the uh, and this shows that the time-dependent pricing can indeed help to reduce the peak demands. In implementing the Tube system, we put the user GUI and the the Tube application monitor on the user's mobile device, iPhone or iPad or Android, and the traffic measurement unit, the weighting function estimator, and most importantly, the price optimizer are on the server side. Our time period of calculating the prices are half-an-hour intervals, and after every half an hour, the new prices are computed for the next 24 hours and advertised to the users. There is also a recommendation engine to facilitate the decision process for the user, whether that is they're willing to wait or not, and this can help to have the autopilot mode of operation. And we have also taken extra caution to ensure privacy and security of the system. In particular, we do not use any kind of deep packet inspection, although doing so along with and even without having to log the data as is permitted in certain countries, in India for example, will definitely improve our performance. So where can we use time-dependent pricing? Today we get only a fraction of the advertised rates of 3G and 4G. And congestion-dependent or time-dependent pricing can take away some of the users to less congested periods, and less interference will then increase the signal quality on a multiplicative scale and making these technologies work. We can take the idea of time-dependent pricing one step further and create a new service class called the ultra-affordable plan users. And these are the users who pay very little for their data access, but also have to wait longer and have very little guarantee on the delays. And the system in this case will operate at fine time scale, with the periods being reduced from half an hour to the order of seconds, and the system will run in an autopilot mode. The idea here is to exploit the flashy white spaces that are in the air. Uh, Even in congested spectrum, during busy hours, every now and then, there are few users who are using it. And there is even more room in less congested hours. So instead of letting these capacity go waste, which are capacities, leftover capacities from expensive data plan users, we can use time-dependent pricing to sell off these white spaces at low spot prices to the UAP service class users. But who are these users? These are the underprivileged people living in urban areas with 3G coverage, but who do not have enough money to pay for it. So using UAP, now the deep pockets continue to enjoy their expensive data plan, while the shallow pockets also now have an opportunity to have access to data by, by being willing to wait for these white spaces to appear. So this slide summarizes the benefits of Tube because it creates a win-win scenario for everyone. For the ISPs, it benefits by reducing cost and congestion and monetizing bandwidth. For the consumers, they benefit by slashing their monthly bills, saving by waiting, and enjoying a hassle-free autopilot mode of operation. Tube also has a social dimension of bridging the digital divide by creating an ultra affordable class of users, and also it helps in expanding broadband access in rural areas by reducing the peak capacity need for the bottleneck middle mile. Next, I will discuss about the different phases of development and the trial of Tube that we are carrying out at Princeton. So, starting with fundamental research in engineering and economics, we came up with system design and algorithms, which was completed, and then we moved to the phase 2 of prototype development, which has been completed now. And our main focus now is on the Princeton field trial, which was started yesterday officially, and we have recruited 50 participants from Princeton's AT&T corporate plan, and they are faculty and staff members of Princeton. In the first month of the trial, we are going to record their normal usage patterns to calibrate our system, and from the following months, we are going to start offering time-dependent prices. Following this, we will carry out a larger customer trial in India with Reliance, the second largest operator in India, in summer and in fall. And the Tube team is effectively a resale ISP now. The different participants are on the Princeton's corporate plan, and the university pays for their real AT&T bills, but we offer the participants a virtual time-dependent pricing plan and monitor their responses, and we offer them rewards in proportion to the flatness of the usage profile under time-dependent pricing. The users or the participants are going to install the Tube application on their mobile handset, and the data from their mobile phones is going to be redirected by an APN from the 3G core of AT&T's network to our lab service and then routed back to the internet. We are really grateful to AT&T for the collaboration and the support that we have received from AT&T Labs and their New Jersey sales team. So before I conclude, I would like to discuss a little bit about the challenges that we faced as we try to move out from the theoretical foundation and have a real-world deployment of the system. We needed to figure out what will be an easy-to-use graphical user interface for the users, and this required a lot of iterations and refinements. We had to be very careful about the privacy issues, and in particular, we were constrained by the need not to use any form of deep packet inspection. Realizing the autopilot mode of operation and to make a tailored custom package for each user that will fit into their monthly budget also required significant thoughts. And lastly, we and most importantly, the challenge that came was from Apple's restriction on the kind of applications that can be developed by third-party vendors. And as a result, we had to create two groups of users, one for the basic version of the Tube application without the autopilot mode that will run on the iPhone of the Princeton participants. And the second group of user will have the full-fledged version of the Tube application with the autopilot mode, and this will be installed on their iPad 2s, which we will be handing out to the participants. And generally speaking, this helped us to realize that there is a greater industrial need to have an interface between the ISPs and the application developers. And so to conclude, Tube is a system of delivering pricing innovations in software which will enable the ISPs to better match their revenues to costs and will provide more options to the users to cope with the increasing overage penalties. Thank you.